Howdy, AP PreCal. It is Miss Kosh. In this video, I want to talk about using the average rate of change with exponential and logarithmic functions. I'm not exactly sure which section this is. I don't know if it's 214, but I definitely have seen stuff like this show up with the free response. So FRQ2, I think, would have stuff like this. So I don't remember who got me inspired with this question, but I used some ideas that I found in the Facebook teacher group and have kind of put some work together here. So we're gonna work off of this picture for this first part, and then I have problems that we're gonna figure out how to do after we know what we're doing here. Okay, so let's jump in and actually do this problem. So what I did is I started with this graph right here. This is just f of x is equal to the natural log, that's an ln of x. Oh my goodness, okay. This doesn't bode well if I can't write natural log of x. This graph becomes, this is the, not graph, this line through here is the secant line that's passing through 2 points of this logarithmic function. Okay, so I think I called it line 1. And so I've got I know 2 points on this line right here. So that's what the directions are telling us here. My function f, my logarithmic function here, is concave. Notice this is concave down on its entire domain, which implies that f is, notice as I'm moving this way, my y values are increasing. So f is increasing at a decreasing rate. Okay, this slope is more steep than this slope, which is more steep than that, and those average rates of change are decreasing as I go over that interval. Okay, so then it says find the average rate of change on the interval. Well, it says the average rate of change on the interval is blank. Okay, so let's look up here. Well, how do I find the average rate of change? They're wanting me to use these 2 points. So we have, well, f of 8 minus f of 2 all over 8 minus 2. Well, you might know that f of 8 is the natural log of 8 minus the natural log of 2 all over 6. Remember our log properties. We can squish subtraction together with division. 8 divided by 2 is 4, so this is the natural log of 4 divided by 6. Now we have different ways to represent this, and we could grab a calculator and come up with an approximate value. I'm not sure that I care, or we could say that it's 1/6 times the natural log of 4, or we could make that the exponent. I think I'll write it this way because it's kind of compact. And actually, so it's 1/6 natural log of 4. Actually, let me see if I can grab a calculator that works. So if I do 1/6 times the natural log of 4, this is approximately 0.23. Approximately 0.2310 if we want to come up with a decimal approximation. Okay, so this average rate of change, we've got a few ways to write it, but here are 2 of them, and it's the slope of the secant line. Okay, so we can so let's see the next thing. Compare this average rate of change on the interval 2 to 8 to the average rate of change on the interval 8 to 14. Okay, well, so if I look from 8 to, well, here's 14. So now we're looking at this slope. And you may notice, I did a bad job of tracing it, but this line here is less steep than line 1. Okay, and so the average rate of change on our first interval, 2 to 8, is greater than the average rate of change on the interval. So the average rate of change on 2 to 8 is, which value is larger? That one, because this line is more steep. Well, why is that? Well, because this was concave down, the average rate of change is decreasing. So if I pick a place where, if I pick an interval where my x's have increased, then the average rate of change is going to be smaller than what I had before. That was kind of confusing. I hope that made sense. Okay, if we use the secant line to estimate f of 4, we will, here's a blank for over or underestimate the actual value. Okay, so if I'm using, do you remember we did this before? Well, maybe we didn't do it before, but we're going to do it again in a second. We're going to use this line. We're going to come up with an equation of the line, and we're going to use that to estimate what we think the value is at a particular spot. Well, you'll notice that since we were using the we're using the secant line between these 2 points. If we're looking at the point in between them and it's concave down, that means that the curve is actually going to be above that line in between these 2 points. So the value that we get here is an underestimate the actual value. Why? Because it's concave down and the value we're looking for is in between the 2 values we know. Okay, so if it's, notice, I hope you can see what I'm describing. Then the next one, it says if we use the secant line to find f of 12, well, notice my curve is going like this. It was concave down going like that. F of 12 is going to be above the line, now my secant line is above the curve because it's outside that interval that I knew. So when it's concave down and you're within the interval, the secant line is below the actual curve. When you're outside the interval that we're looking at, then it's going to be above. So now, when we use this, if we use the secant line to estimate, it will be an overestimate of the actual value. Why? Because we are outside the interval, and so our secant line is above our curve since our curve is concave down. Okay, hopefully that wasn't too confusing. Let's try an actual problem. Okay, now without your graph or your calculator, so we're going to talk about what we know. So in this first one here, this is the negative log base 2 of x minus 3 plus 1. So I have, my graph is going to have an asymptote at 3 now. I'm going to have, instead of going something like this, I'm now going something like this, but I've moved up 1. And so I have kind of this point. Oop, well, that looks terrible. But we're doing something like that. Okay, so what is happening here? Well, we're decreasing we're concave up, so it's decreasing at an increasing rate because this was concave up. Okay, so find the average rate of change. Hopefully I wrote these problems and I was trying to make them nice and then I haven't worked it yet. So here we go. So let's look at f of 11 would be equal to, a plug in 11 minus 3 is 8. Oh, good. Okay, log base 2 of 8 is 3, so this becomes a negative 3 plus 1 is equal to negative 2. F of, what was the other one? 5. Negative, so 5 minus 3 is 2. Log base 2 of 2 is 1, so this becomes negative 1 plus 1. That's equal to 0. Okay, so now how do I find the average rate of change? I'll do f of 11 minus f of 5 all over 11 minus 5. I write this out every time because it helps me. And so what was f of 11? Negative 2 minus 0 over 6. Okay, so negative 1/3. Okay, that's not terrible. Okay, so which is greater, the average rate of change on the interval 5 to 11 or the average rate of change from 11 to 15? That's not a 15, that's a 19. Well, so I think it's decreasing at an increasing rate. So this first one had an average rate of change of negative 1/3. The next average rate of change will be something that is less negative. So it's this interval is going to be our answer. Basically what's happening here is it will still be negative, but like if we looked at here is negative 1/3 and here is 0. Our answer, our slope, our average rate of change somewhere is going to be somewhere bigger than negative 1/3. Okay, do you want me to prove it to you? If I plug in, I don't really feel like it. Let's do it this way. Well, okay. If I plug in 19, I have negative, oh dear, math, there's log AB. Log AB, okay, 2, this becomes, I was going to do 19 minus 3 plus 1. I'm going to store that as alpha A. And then I'm going to do the exact same thing, negative log base 2 of, what was it, 11? Oh, no, we already know that value. This was equal to negative 2. Okay. So now, if I'm doing the average rate of change, did I know that was negative 3? Oh, what do you know? I'm smarter than I knew. Minus negative 2 all over 19 minus 11. Yes. is negative 1/8. Okay, negative 1/8 is less negative than negative 1/3. Okay, sorry, that was, I diverge. Okay, use this, so f of 5, which is 0, and the average rate of change to find an estimate. Okay, so with this one, we can, the way that I find other pre-cal teachers doing this online doesn't quite make sense to me. So what I'm going to do is I'm going to say the average rate of change would be equal to f of 8 minus f of 5 all over 8 minus 5. And then I'm going to plug in what I know. What I know is my average rate of change, they said to use the average rate of change from part A, which is this, negative 1/3 is equal to average rate. We don't know f of 8. We do know f of 5 is equal to 0. Well, that's convenient. And this is divided by 3. So I'm going to multiply both sides by 3, and I get negative 1 is equal to f of 8. What was it actually? If I plug in 8, where we're taking, that becomes log base 2 of 5 is not, log base 2 of 4 would be equal to 2, so negative 2 plus, it's close, but it's obviously an estimate. Okay, so now let's see what's happening here. We were using the average rate of change. I'm going to sketch this, okay. So, I don't know that I need that line. Okay, here we go. We've got this curve. It's decreasing at an increasing rate. It's doing something like this. We knew the values at from 5 and 11, wherever those are, and then we were estimating something. So we found a line here. Ooh, that looks terrible. Okay, between 5 and 11, and we wanted to find the value here. And so since this is between our 5 and 11, 8 comes between 5 and 11, and it's concave up, that means the curve is going to be below the secant line between these two values. And so the value that we get here is going to be an underestimate. And I hope that made sense. Okay. This is definitely something I'm still working through, so hopefully I'm able to explain it to you. If not, I will keep trying. Okay, let's look at another one. Here goes nothing. So this graph, let's rewrite this as negative 3 times a negative x is now this minus 4. Okay, and so what's happened? Well, I took the graph y equals 3 to the x, which looks like this. And then I reflected it and reflected it. So this would be that. And then this, negative 3 to the negative x, would be that. Okay, and then I shifted it to the right 4. Okay, so it's still, but basically what we need to know is that this graph is going to be increasing. It's increasing on concave down, so it's increasing at a decreasing rate. Increasing at a decreasing rate. It's concave down. Okay. Find the average rate of change on that interval. Okay, so let's do, so our average rate of change will be equal to g of 3 minus g of 1 over 3 minus 1. Plug in 3. I tried to make the numbers nice to work with. 4 minus 3 is 1, so this is negative 3. And then plug in 1. 4 minus 1 is 3. That's 27, but it's negative. Minus a negative 27 all over 2. This is a positive now. 27 minus 3 is 24. Divided by 2 is 12. If you catch any mistakes in my videos, tell me nicely down below. I do the best I can. I'm good, but I'm not perfect. Okay, which is greater, the average rate of change on the interval 1 to 3 or the average rate of change from 3 to 6? Well, it's increasing at a decreasing rate. So that means that first one, 1 to 3, was going to be a larger value. We can look again. 1 to 3, wherever that is, this is going to be less steep than that. That was terrible, but hopefully that made sense. Okay, use g of 3 and the average rate you found in part A to estimate g of 5. Okay, so the way I do this, the average rate of change is going to be equal to g of 5 minus g of 3 all over 5 minus 3. The average rate of change we found to be 12. We don't know g of 5. We know g of 3. Where did it go? G of 3 was equal to negative 3 minus a negative 3 all over 2. Multiply both sides by 2, I get 24 is equal to g of 5 plus 3, subtract 3, I have g of 5 is equal to 21. Okay, so now there's my estimate. So what is this, an over or underestimate? Well, we found, okay, so what were we doing? Our graph looked something like this. We were using the average rate of change on the interval from 1 to 3. So here's 1, here's 3. I don't even care where it really falls. I just need to know that this is, now we were estimating 5. Well, so notice, so since this was concave down, it's going to be, between these two, the curve will be above the secant line, but beyond that, the secant line will be above the curve. The curve will be below the secant line. So this value that we just estimated would be something like this, is where x equals 5 on that secant line. That's going to be above the actual value on the curve. So this is an overestimate. I think I'm right. If I'm not right, tell me down below or link me to somebody else's better video. We're still figuring all this out, but this is great fun. Hopefully that was helpful. Like, subscribe, comment, and of course, go practice.